So for our data sets, we have about 10 data sets in total, and they are going to hold valuable information for us. So the first data set I want to look at is called stock underscore symbol underscore name. And as you can see on the screen here, it basically contains the stock symbol and the company name that is related to the stock symbol. So there are about 91 stock symbols or about 91 companies in here. And I'll definitely add more as I become more and more interested in companies I've never heard about and they have a stock on the stock market. So this file is the basic starting point for me. So everything here, everything that you see here was typed out. So WBA, Walgreens Boots Alliance, 91 stocks, all of that was typed out by me. I looked up the company name and then went on from there. And like I said before, I'm going to add stocks, but I have to keep in mind that the more stocks I add will increase to a longer runtime to the other programs that I have. But that's basically it for this data set. Nothing very too complex. It's just basically me writing out the stock symbol and the company name associated with it. So the next data set I want to look at is called date underscore table. This data set contains records starting from the 1800s all the way up to the year of 2025. The unique identifier is of course the date because it'll only appear once, but then we could also break down the date into multiple columns like the year, the date, or even the quarter it's in. The main reason for this table is mainly so for like a gateway table. If I need to make a connection between two tables but I can't do it directly, then this date table should be able to help me connect those two tables together as being some type of bridge. So you can see the file has finally opened and we have the columns of date, year, month, date underscore month, and day. For the most part, they should be self-explanatory except for date month. That's just basically a different format. I just basically put the wrong column name for it, but that's not really a big deal. We can always go back and rename it if anything. And you can see here we start from the 1816 all the way up to December 1st, 2025. And like I said, this data set will act like a bridge between two other tables in our database diagram. There's nothing really else special about this data set, so we could move on to our next one. On to the next data set, and for this one is mainly used for our time series analysis or when we are going to try and predict the future closing price of a certain stock symbol. So this data comes from data.worldbank.org. As the file downloads and opens from worldbank.org, I'll tell you what this file contains. So it contains all of the countries and their gross domestic product for every year from 1960 all the way up to 2018 if that data is available. But in my case, I don't need to see all the countries. The only countries I am interested in is the United States, and they have a country called World, which is basically all of the world GDP put together and added as one. Basically that. So we are going to use those two columns or those two rows because we have a bit of a matrix table here. And this data set actually does get cleaned up and looks a little bit prettier at the end. So we are only going to take two columns and we are going to have their GDP data from 1960 all the way up to 2018. But first, this is what the original file looks like when it has not been cleaned yet. So this is what the final data set looks like. So as you can see, we turned that matrix table and we transposed it. So now the year or those year values become the rows and vice versa for our country. So we have the columns of year, United States, and world. And you can see that we have data from 1960 all the way up to 2018. I only have to do this data cleaning process once because I have another file that contains macros that will clean the original GDP data file and turn it in to make it look like this. So whenever the website databank.org comes out with new GDP data, I can easily download it, put it in this file location, and run my macros for it. Alright, so now we are moving on to the more interesting data sets. But before we get into that, I'll talk about the first library I used in Python to grab our historical stock data. So one of the goals with this project, or something I wanted to accomplish, was to be able to web scrape. And web scraping historical stock data proved to be a little bit more challenging than I thought it would be. To make a long story short, I basically came to the conclusion that for me, and maybe for other people, that it's really hard to pull historical stock data from the web because there's multiple variables. Well, the main one being that you need to be able to search for different date range. But upon my research, I was able to find a Python library called yfinance. With this library, it made this project a lot more easier because now through Python, I was able to search for any stock symbol and grab historical data based on the date range I gave it to. And with this information already being in Python, I could then turn the historical stock data into a data frame and export it as a CSV file or even a text file. So you can see here on the screen now that this library was created by Ran Arausi. He is also the same person who maintains this library as well. You can also see that in his demo coding that from the first 5 lines, we have all the information we need for this project. Well, a majority of it. So with his library, all you would have to do is enter in a ticker symbol and then select the period or the date range that you want. You can have it from a 7-day period, 2-week period, a month, 3-month, even the maximum period, which you see on the screen now. So all we would have to do is create a loop that looks at our stock symbols in our stock symbol file and retrieve the historical data for each stock symbol in that file, and then we would just have to output it to a data frame. Now that we have taken a look at the yfinance library, we are going to create our first data set using this library. With the programming, I'm going to try my best to try and explain everything clear and concise, but if you have any questions, feel free to contact me. Also, it doesn't have to be just about the programming, it could be about other sections covered in this video series. With our first box, we are going to import the yfinance library and the pandas library. We already know what the yfinance library does, but for the pandas, we are going to use it to read files in and create a data frame with the data that we pulled from the yfinance library. In our second box, we are going to create a variable called stock, and this will use the pandas library to read in our text file. Our text file is stock underscore symbol underscore name, and this is the data set that we looked at earlier where it contains all the stock symbols and the company name behind it. With our file now being read in, we could start to try and create our loop. So in the third box, we are going to create another variable called df2, and this is basically an empty data frame. We create an empty data frame because within our loop, we are going to create another data frame that will hold the current stock symbol history, and then that data frame will append to our data frame on the outside, which is called df2. If we didn't have the variable df2 on the outside of our loop and only had the df variable on the inside of our loop, we will only see the last stock symbol history. So whatever the last stock symbol in our stock underscore symbol underscore name text file is, when we go to look at the df data frame, we will only see that last stock symbol. So let's say, for example, if it was WBA and we know we have multiple stock symbols in our original file, the last stocks or the only data that we are going to see will be historical data for WBA or Walgreens. With that being said, we can now take a look at the first line of our loop. So we have for symbols in stock underscore symbol, and I'm going to explain this first line quickly and what it means. So it's saying that for every stock symbol in our original file that we loaded in, we are going to perform these steps. So let's start with an example first. So in our data set that we loaded in, stock underscore symbol underscore name, the first stock symbol in there is WBA. So for this loop, WBA is up first, and for WBA, we are going to create a variable called SS equals YF.ticker, and then we have the argument called symbols. So currently we are on the first stock symbol, so it's going to look at WBA. Once the YF ticker function finds the stock symbol, we then will create another variable called his. His is a variable that will find the historical data for our current stock symbol. We also have the option to choose different time periods. So in this first loop, we are going to look at the max time period. Basically, from when the stock first started trading, to the current day. So today is December 3rd. So Walgreens, whenever that stock first became public, all the way up to December 3rd. After that, we are going to create a data frame, and it is going to hold the historical data. Now, with our historical data, the one thing about it is that when you search for it on the Y Finance library, it doesn't tell you which stock symbol you're looking at. So let's say if we search WBA, we could of course see all the historical data for WBA for each and every day, but it won't tell us the stock symbol. We would just have to know from previous lines of code which stock symbol we are looking at. So this is why in the next line of code where it says df stock underscore symbol equals symbols, this creates a column in our data frame that will add the current stock symbol next to the historical data in our data frame. Once that stock symbol has been added to our df data frame, we will then append the df data frame to the data frame on the outside, which is df2. Append basically means just to update. So with the first stock symbol done, this process is repeated for every stock symbol in that dataset file that we loaded in. Once all these stock symbols have been found and they have the historical data, we would then export it to a CSV file called stock underscore history.csv. As of now, this data set for the first loop that we created contains about over 600,000 rows. And like I said earlier, more stock symbols are going to be added. And with the addition of more stock symbols being added, it's going to result in more rows. In our fourth box of coding, it's basically the same concept, but we are going to look at the historical data for the stock symbol at a 1 week period. So you can see period equal 7D. So that means one week or 7 days. And the file that we are going to export it is called stock history underscore one_week.csv. Another thing to note is that within our loop, we have a print statement. Print in parentheses symbol. So once this loop is completed or just about going to be completed, we are going to print the stock symbol. That is the last step. This step is here for because when I run the code in the command prompt, I would like to see where the progress of the coding is at. So which stock symbol is it on, or which stock symbol has it complete? And you can see in the output that stocks in original file, and then you have Walgreens was complete, Ali Financial was complete, Visa was completed, so on and so forth. So when the command prompt comes up, I have a good understanding of where the coding is at or which stock symbols have been completed. And to finish up the programming, we have a final print statement that shows us, or excuse me, that tells us that both files have been updated and we can move on to the next step. So anytime the program is completed, our file should be updated to the current date that the program was ran, and we should also get this print statement at the end. So this is what the final data set looks like. You have the date, adjusted close, dividend, high, low, open, stock split, stock symbol, and the volume. And we're almost approaching over 700,000 rows. One last note, this is the largest data set out of any of the data sets we are going to look at.